Okay, we're going to do a new system, or making a new video here. We're going to do this all via the Ladybug so that you guys can not have that glare. So today we're going to talk about solving systems by graphing. This is just one of the three methods we talked about in the prior video. We're going to solve these systems by graphing. Again, there's three types. If we review this, there's three types of system or solution possibilities. There is no solution. Okay, no solution means no intersection. Then you have infinitely many solutions. Infinitely many is when you essentially have the same line. Talked about that before. And then your third option would be one solution. And one solution means one intersection. That's it. Those are your only options. That's kind of a little quick review. Those are your only options for solutions to systems of equations. And again, I forgot to mention this before we got started, but if you need to pause the video, there are notes online. Go ahead and print these notes off. Again, it's on Blackboard on the left-hand side there. It's under week 3.3. Print these notes off before we get started so you have these. Also, make sure you come to class tomorrow with graph paper. You're going to need graph paper to do this stuff tomorrow. All right, so let's go ahead and get started. Let's solve each system by graphing. The first one is y equals negative x minus 1. Okay, we're going to solve this by looking at the y-intercept first, we're going to graph this by looking at the y-intercept first, which is negative 1. So we're going to go down here to negative 1 on the y-axis. And then we're going to follow our slope. Our slope here is just because you see that negative there. The slope means it is negative 1. There's an invisible 1 there. So I have negative 1, which is the same thing as saying negative 1 over 1. So what I'm going to go, and I'm going to go down 1 over 1. And I can do it again. I can go down 1 over 1 and draw another dot. And I apologize, these graphs are not very clear as far as the grid lines go, so just do the best you can on the notes here. And then I just draw my line. And again, one of the things that's going to be extremely important when you solve systems of equations using graphing is to make sure that you draw straight lines. You've got to make sure that you draw straight lines. If you don't draw straight lines, it's possible that you could end up with the wrong solution. All right, so let's look at the next one. On the next one, we have y equals 3x plus 7. Okay, I'm going to start at 7 on my y-axis. It's somewhere in here, right about there. And then I'm going to look at my slope, which is 3. It's the number in front of the x, which turns into 3 over 1. So then I'm going to go up 3. 1, 2, 3. 1, 2, 3. And then over 1. It's right in there. And then I'm going to draw my line. Okay, now clearly you should be able to tell right away, based on what the graph looks like, that you have one solution. That solution is going to be found right here at their intersection. So what we need to do is we need to find out what their point is. What is that point of intersection? So, and mine is a little bit off, but if you go over to -2 and up to 1, it should be -2, 1. But again, because the grid lines are off, it's off a little bit, but the solution here is negative 2 comma 1. That is where the intersection occurs. This is why it's going to be important to bring your graph paper tomorrow, because having graph paper will make sure you have an accurate answer. But the answer to this system is negative 2 comma 1. That is found by just simply going over here and looking at that point right there. What are the coordinates of that point? All right, so we have one solution, and if I name that solution, it's negative 2, 1. All right, let's look at number 2. Okay, number 2 is y equals negative 8/9 plus 3. And then you have y equals 1/3 minus 8. Now, just by looking at the slopes of this, you can tell that these lines are going to intersect somewhere because they have different slopes. You can also tell that they're going to be just intersecting lines. They're not going to be perpendicular because these are not the opposite reciprocal of each other. Okay, so let's just graph it and find out what's going to happen. Again, I'm looking at my y-intercept, which is 3. So I'm going to go up to 3 on my y-axis. There's 2, 3 right in here. Then I'm going to follow my slope. I'm going to go down 8. It's negative 8/9. Again, negative 8 over 9. Go down 8. 1, 2, 3, 4, 5, 6, 7, 8. And then I'm going to go over 9. So if I'm on the y-axis, I go over 9. That's to the point of 9 over here. And I can count it out. 1, 2, 3, 4, 5, 6, 7, 8, and 9 right in here. Okay, I've got 2 points. Let's go ahead and draw our line. Again, make sure you always put arrows on it to indicate that it is infinite. All right. Now let's go ahead and graph the other one. Start at negative 8 down here. Plot your point. That's my y-intercept. Negative 8 is my y-intercept. Plot that point down here. And then the slope is rise is 1, so I'm going to go up 1, and the run is to the right 3 because it's both positive. So I'm going to go up 1, over 1, 2, 3. Should be somewhere here. Got 2 points. Unless the points are really close together, you can go ahead and graph, draw your line with just 2 points. Again, we see that we have intersecting lines. This is off a little bit. So because we have intersecting lines, we know we have at least one solution. That solution is going to be found right there. So I need to find out what point that is. If I go over here, it should be 9 and down to a negative 5. This point right here is 9 over negative 5. So my solution is 9 comma negative 5. Remember, the solution, the name of the solution is an ordered pair. So again, my first 2 examples both had intersecting lines. The solutions of those intersecting lines are right here. That is the point. 9, negative 5 is on both of these lines. That's why they intersect. That's the only point that they share. That's very important that you understand that. Okay? Let's look at another one. And this is great graphing practice as well. Okay, now we're going to do x equals 7. Okay, I'm going to go over to 7 on my x-axis. Right in here. Plot my point. I know because it's x equals 7 that this is a vertical line. You've got to have that memorized. You should know that graphing x equals 7 is just a vertical line. So I'm going to draw this line straight up and down. We should also know that the solution to our system is going to have a 7 as the x value, because x value for here is only 7. So let's go ahead and grab the other one. The next one is -11/7 x plus 2. So I'm going to go to 2 on my y-axis, plot a point. Then I'm going to go down 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It's right in here, and then I'm going to go over to the right, okay, because I went down, that's my negative movement. Now I'm going to go over to the right, positive 7 spots. 1, 2, 3, 4, 5, 6, 7, right there. And it is right on that other line. So I'm going to draw my line. Again, if I move this up a little bit, you can see we clearly have intersecting lines. Here's our intersection point, and that is our solution. It's going to be -11. I'm sorry, excuse me. It's going to be 7, comma, -9. If I go over here, I go over to 7, I come down to -9. That's my solution. 7 over -9. Again, one solution, because it's intersecting, my one solution is 7, comma, -9. Notice how I have not said anything about 2 solutions, 3 solutions, 4 solutions, because that does not make sense. Alright? Let's look at our next example. You have y equals 9. Okay, I'm going to go grab this. I don't have an x value. That means my m is equal to 0 because there is no x. 0 times x is what eliminates the x. If you see y equals a naked number, you should know that you just go to 9 on the y-axis, plot a point, and this is a horizontal line. You draw your line horizontal through number 9 on the y-axis. Okay? My next one is -1. I start at -1. It's my y-intercept. Plot a point there. Okay? Then I'm going to go, this time I'm going to do a little different. I can only move negative one direction. Well, if I go down -10, I'm going to be off the graph. I can't go down -10, so I'm going to go +10. So I'm going to go up 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 is right here. And then I'm going to go over to the left, -7, because I went up my positive. In order to make this negative, I've got to go to the left now, 7. So I'm going to go over 7. 1, 2, 3, 4, 5, 6, 7. Right in here. Okay? You got your 2 dots. Now go ahead and graph your line. Again, clearly we see we have intersecting lines. Because we have intersecting lines, we should have one solution. Here's our intersection point, is also our solution. Where it intersects, that is our solution. So now we need to figure out what that point is. So what we do is we count over first. So we're going to go over -1, 2, 3, 4, 5, 6, 7. It's -7 over. And then go up, looks like to about 9. So the answer here is -7, comma 9. -7, comma 9. So our answer to this system of equations would be -7, 9. That is the point they both share. All right. Let's do a few more examples. Let's look at this one here. Now, again, we can go ahead and start. I want to go ahead and combine the two units that we've talked about, or the two things we've talked about already. Parallel, perpendicular, intersecting, and I want to talk about systems a little bit as we do this, because I want you to connect 2 and 2 together. If I start this, before I start graphing, if I evaluate the slopes, I can tell what's going to happen. This slope is different from this slope. Therefore, they're going to intersect. Okay? If I know they're going to intersect, I'm going to go ahead and graph them to find my solution. That's what I want to know right now. There are different slopes, so they're going to intersect, so let's go ahead and graph it. So I have y equals y equals 8/5 x minus 1. Okay? So y equals 8/5 x minus 1. Let's go ahead and start at the -1. Pull this up a little bit. Plot my point on the -1. Then I'm going to look at 8 as my rise. And I'm going to go up 8 from that -1. I'll go up 8. 1, 2, 3, 4, 5, 6, 7, 8. And then I'm going to go to the positive 5. I'm going to go to the right because they're both positive. So the right 5. 1, 2, 3, 4, 5. Plot my point there. I've got 2 points that are pretty good distance apart. So I can go ahead and draw my line. Again, it's very important to be accurate on here. I know you can see me kind of taking a little more time when I put the ruler out here, but the more accurate you are, the better off you are. All right, the next one is y equals -1/5 x plus 8. Again, in this case, I'm going to start on my positive 8 up here. That's my y-intercept. Plot a point. I'm going to go down 1 because it's negative, and then I'm going to go to the right. I got to go my positive direction. Now, you're always going to move at least one positive direction. I'm going to go to the positive 5. 1, 2, 3, 4, 5. Right in here. Okay, this got a very small slope, or a very small magnitude, if you will. Go ahead and graph my line there. Again, we already knew this was going to happen because we evaluated slopes, but we have an intersection. We want to make sure that we understand that that intersection is our solution. So we need to find out what that point is. If you go over here, you see you're going over 5 and then up 7. So our solution here is 5, 7. That is the solution to this system of equations. Okay? Let's look at our next example. Next we have y equals 2/3 x plus 1. And then we have y equals -2/3 x minus 3. Now be careful here. Let's evaluate the the slopes real quick. Upon evaluating the slopes, we see we have a 2/3 and a -2/3. They are different because they have different signs, so they are going to intersect. Now be careful here. Not that perpendicular means anything in systems necessarily, but they are not perpendicular because while this is the opposite of 2/3, it is not the opposite reciprocal. I just want to kind of throw that in there for a review concept. They are opposite of one another, but not opposite reciprocal. And they are going to intersect because one's positive, one's negative. So let's go ahead and graph it and find our solution. Again, we're going to start with our y-intercept of 1. Plot my point on my 1 right there. Then I'm going to go up 2, 1, 2, and then over 3 to the right. 1, 2, 3. Somewhere in there. I've got 2 pretty good points there. Draw our line. Let me move that up for you to see it better, sorry. So there's our line right there. On the next one, we're going to go down to -3 because that's our y-intercept. Plot a point. Then I have a -2, so I'm going to go down 2, 1, 2, and then I need to go to my positive direction now of 3 in order to make this a negative slope. So I'm going to go over 1, 2, 3, plot my line there. Got 2 pretty good points. So let's go ahead and make this line. Again, we talked about it before we graphed it, that this was going to intersect. Guys, don't undervalue the idea of assessing your graphs first. What I mean by that is go ahead and look at those slopes first to see if they're going to intersect so that you know what to expect. You should have expected this graph to intersect. Since it's intersecting, we're going to have one solution. That solution's right there. And if we look, again, I think it's off a little bit, but it should be over 1, 2, 3. It's over -3, and then down -1. So our solution would be -3, comma, -1. Again, I think that the drawing or the picture's off just a little bit, but that's what it is. That's why, again, I'm going to repeat myself, bring that graph paper tomorrow. All right, 2 more examples and then we're done. Now, here's where it gets a little tricky. If you see here, we have x minus 2y equals 4, and you have 2x minus y equals -1. Okay, the problem here is we don't have it in slope-intercept form. If it is not in slope-intercept form, you're going to have to solve this equation to put it into slope-intercept form. Okay, so let's do that first. So I want to solve it. So I have x minus 2y equals 4. I want to solve this for y. I'm going to subtract x from both sides. This cancels. Notice, and it leaves me with a -2y. Notice that I cannot combine those because those are unlike terms. So I'm just going to bring that negative x in front. And that's a positive 4. I'm bringing those down. So solve for y. I have to divide both sides by -2. That means I'm dividing everything by -2. This cancels, leaving me with y equals. Negative and negative cancels out, so I have x divided by 2 plus, 4 divided by -2 is minus 2. So this equation right here turns into y equals, and now here's the thing, this x divided by 2 is the same thing as saying 1/2 x minus 2. So this equation becomes 1/2 x minus 2. Now I can graph that. But let's go ahead, since we're already in the mode of converting, let's go ahead and convert and see what we come up with. I would convert both first, because if you don't have to graph because they're parallel, then I would convert to make sure I see if they're parallel or not. So let's convert the second one. So here's the second equation. 2x minus y equals -1. Solve for y. I subtract 2x from both sides. That cancels, leaving me with -y equals -2x and -1 don't combine, so I'm just bringing them down. Okay, and then I'm going to take this negative and throw it over here. And it goes to both of them. So then I have y equals negative is a positive 2x, negative and negative is a positive 1. So this equation then turns into y equals 2x plus 1. Look at their slopes. They are different. Therefore, they're going to intersect. So let's go ahead and graph it and see what we come up with. First we're going to graph is y equals 1/2 x minus 2. So I'm going to start with my -2. I'm going to move this up a little bit. Start with my -2. And I have a positive slope, so I'm going to go up 1. And then over 2. Sorry. This graph changed on us a little bit. Okay, now I have 2 good points. I'm going to change this color because it's going to overlap with the work that we did over here, so I'm going to change it. So here's our graph. The next one I'm going to graph is y equals 2x plus 1. So I'm going to start on the 1, which right here. And then I'm going to go up 2, because remember, the slope is 2 over 1. So I'm going to go up 2, 1, 2, and then over 1. And then I'm going to draw my line based off those 2 points, those 2 good points there. And again, before we even did this, we knew these were going to intersect. If I pull this up a little bit, you see the intersections right here. So it's going to have one solution. So I need to go ahead and find out what that point is. Where is that point? So all I have to do is find the ordered pair for that point. I'm going to go over -2. I think I'm off a little bit again. And then down to -3. My line's off quite a bit on this one. But the solution here is -2, -3. And again, graph paper, graph paper. Make sure you bring real graph paper tomorrow. All right, finally, the last example. Again, we're going to solve this. For y. So if I solve this for y, the first one, 3x minus 2y, I'm going to bring it down just a little bit. 3x minus 2y equals -8. Solving for y, subtract 3x from both sides. Again, I have -2y equals, these do not combine. So I'm just going to bring down the -3x in front and bring down the -8 in the back. Divide both sides by -2. That cancels, leaving me with y equals -3 divided by -2. It's just +3/2. Do not change that to a decimal. Keep it as a fraction. Cancel out your negative signs. And then -8 divided by -2 is +4. So here's one line. Now let's solve the other one to see what it comes out to be. I have x plus 2y equals -8. I'm going to subtract x from both sides. It's going to cancel, leaving me with 2y equals -x minus 8. Divide both sides by 2. That cancels, leaving me with y equals, I'm just going to go ahead and convert this to -1/2 x plus 4. Sorry, that's off the screen a little bit. So my next one, I'm going to rewrite this so you can see. It's y equals -1/2 x plus 4. Now, before we get started on graphing this, I want to point out a couple things. Again, let's evaluate the slopes. When we look at the slopes, you have 3/2 and then you have -1/2. They are not going to, they're not the same, so they are going to intersect. Because I know they're going to intersect, I know I'm going to have at least one solution. So I'm going to need to graph this. But let's take a look here. If you look at the y-intercept here is a +4, the y-intercept there is +4. They have the same y-intercept. That is a point on the graph. What that means is they are going to intersect on the y-intercept. I really don't need to graph this to know that my solution is going to be 0 over 4 up, because they have the same y-intercept. But let's graph it to go ahead and prove it. So the first one, I'm going to 4, and then I'm going to go up 3. So I'm going to go down 3 this time, just for the difference. 1, 2, 3, and I'm going to go over to the left 2. 1, 2, because two negative movements makes a positive slope. So here's the graph of this one. The second one is at +4 again, and this time I'm going to go down 1, and then over to the right, 1, 2, in order to make a negative slope. We see there's an intersection. We knew that was going to happen. There's our intersection right there. Now look where it's at. It's right there at the y-intercept. It's on 4 on the y-axis. So again, we were right in assuming that 0, 4 was our solution. If you're good at systems and you're good at math and you understand this, you know you don't even have to graph this to get the right answer. So that's it. That's 8 examples of how to graph to find a solution. If I was to graph this and have 2 parallel lines, what kind of solution would I have? The answer is no solution. If I was to graph this and both lines were on top of each other, I would have a solution of infinitely many. But all 8 of these examples were examples of one solution. Again, if you have any questions, come see me tomorrow in tutoring at 8:25. Just a reminder, there will not be that morning retest tomorrow. It will be picked up again on Friday. And again, we have a quiz Friday, so you need to be getting this stuff down and make sure you bring graph paper. Good luck. Have a good day.